Similar to the Mann-Whitney-U is the Wilcoxon signed ranks test. Now the Wilcoxon signed ranks test is a version of the dependent samples t-test that can be performed on ordinal or ranked data. So here's some ordinal data displayed in the table. I'm asking, is there a difference between before and after using an alpha level of 0.05? So we're going to do a Wilcoxon signed ranks test, just like any other statistical test. And our first step is to state the null and alternative hypotheses. Now remember, this is just like a dependent samples t-test, so our null is that there's no difference between the two treatments, and the alternative is that there is a difference between the two treatments. Our alpha level, as I said, is 0.05. And now our decision rule. This is going to follow a z distribution. Now usually you want your sample to be greater than 20. We actually have 6 people, so that's definitely not greater than 20. But we're still going to go ahead and do this. I just made the sample size smaller, so it'd be easy for us to do, and it'd be easy for you to understand. But realize that when you're doing this test, you want a sample size of at least 20 in order for it to follow the z distribution. But I'm going to continue on. So alpha of 0.05, we have a z-test, we end up with a critical z of 1.96. If you don't know how I got that, you can go back to one of the lectures on z-scores, just to double check. So our critical z is 1.96. That means that if the z we calculate is less than negative 1.96 or greater than positive 1.96, we will reject the null hypothesis. So here we go. Here is our data, just organized in a different way so we can work with it. And now we're going to calculate difference scores. This is just like a dependent samples t-test. We have difference scores. So now we're going to throw away the original stuff. We just care about these difference scores. So now what we're going to do is rank these difference scores, where the lower the number, the lower the rank, and the higher the number, the higher the rank. So our lowest number, negative 14, is ranked 1, and our highest number, 21, is ranked 6. So now we're going to add together all of the scores for the positive ranks, and we're going to add together all the scores for the negative ranks to get these two different R's. Now our positive ranks are 4, 5, 6, 2, and 3. Those are all associated with positive numbers, so our positive R is 20. And our negative R is just 1, because rank 1 is associated with negative 14, and that's the only negative number. So we just have 1 there. Now we're going to use this to find a t. T is just the smaller of those two numbers. So our t in this case is going to be 1. And now we're going to use this t to calculate our z. Now this equation is actually pretty easy. All we need is t and n. Our t is 1 and our n is 6 because we have 6 people. So we just put all that stuff in there. And if you have a calculator, you work through that. It's not too bad. You actually find a z of negative 1.99. So now we can go to our results. Remember, we were going to reject if we had a z less than negative 1.96 or greater than positive 1.96, and we had a z of negative 1.99. That's just less than negative 1.96, so that means we can reject the null hypothesis. And we're going to conclude that there is a difference between the before and after groups using a Wilcoxon signed ranks test.